We are opportuned to have a distinguished scholar, a renowned scholar amidst us. Please permit me to read his brief biography so that we can kickstart right away. I would put off my camera and allow Prof Charis to put on his camera so that we can all put a face to the name. All right, Prof Charis M. Galanakis is an internationally recognized scientist, consultant, educator, and editor, specializing in food science, environmental engineering, circular bioeconomy, sustainable innovation, and food systems resilience. He is widely acknowledged as a pioneer of food waste recovery and developed the universal recovery strategy for converting food processing byproducts and agro-industrial waste into valuable resources. With more than 25 years of professional experience, Prof Charis serves as Research and Innovator Director of Galanakis Laboratories in Greece, a distinguished visiting professor at the University of Johannesburg, and an honorary professor at Taif University. His research focuses on food security, climate smart production, circular bioeconomy, digital transformation, and sustainable food systems. He has received numerous international accolades, including recognition as a highly cited researcher by Clarivate, and ranking among the world's top 2% scientists, according to Stanford University and Elsevier. His scholarly contributions include over 300 publications, more than 17,000 citations, an H-index of 62, and over 50 scientific books. He currently serves as the editor-in-chief of Discover Foods and Discover Environments, which are journals of Springer Nature, and has contributed to over 70 international research and innovation projects across more than 20 countries. Colleagues, it is my great pleasure to introduce our guest speaker today, Professor Charis M. Galanakis, who would take over from here. Thank you, and you're welcome, Prof.
Thanks a lot for the introduction and also the invitation to the event. Let me share my screen. Tell me if you... okay, do you see my screen?
Yes, Prof, we can see it.
Perfect. Okay, thank you. Okay, so I'm Charis Galanakis. I'm from Galanakis Laboratories, and it's a pleasure to join the FEWS webinar series of the Center of the Cyber and Physical Food, Energy and Water Systems at the University of Johannesburg. Today, we'll present you WASEC, that is a scenario-based model and decision support tool for food loss, food waste, and food security. The tool is being developed within the SecureFood project, the European Horizon project. It's expected to be launched next month. So the starting point of this tool is a critical, practical question. How can we reduce food loss and waste without creating unintended negative effects on food security? So WASEC is designed to support this question with data, indicators, stakeholder inputs, and scenario analysis. The concept of WASEC is to connect two areas that are often treated separately: food loss and waste on the one hand, and food security on the other. The tool combines several types of information. This, for example, stakeholder inputs, national and sectoral food loss and waste data, food security indicators, namely the Global Food Security Index from economies and related data sets. So these inputs help us to understand not only the current situation, but also the interconnections between food loss and waste and the wider food security system. In practice, the tool follows three main steps. First, it integrates existing metrics and datasets. Second, it identifies interconnections between food loss or waste and food security drivers. And finally, third, it evaluates possible intervention and estimates their expected impact after implementation. So the aim is to move beyond isolated actions and support informed system-level decisions. Our methodology begins with the mapping and quantification of food loss and waste streams across the food supply chain. We first revise the relevant value chains and identify critical generation points where food loss or waste occurs. Now, depending on the role in the chain, this may involve production, processing, distribution, retail, or consumption. For quantification, we screen the available data sets and methodologies. These include food security indicators, as I mentioned, the Global Food Security Index and also the Food Security Index. Both of them are from economists, as well as other food waste and food loss indicators, and the Eurostat food waste datasets. These are complemented by research reports, case studies, information and end-user data, including survey-based evidence. And this is important because the tool should it's not only purely theoretical, it needs to be grounded in real-world data and the practical experience of the stakeholders who will use it. At the core of the tool FEWS is the SecureFood Index, an index that we constructed as the sum of percentages contribution from 6 food security pillars. These are the availability, access, agency, stability, sustainability, and utilization. For each pillar, we use selected parameters to identify through data review and literature analysis. The mathematical model then allows us to estimate how each parameter contributes to the overall SecureFood Index. The model also captures 2 types of effects. First, it captures the effect of user inputs, such as food waste or food loss and annual production. Second, it captures the effect of scenario selections, meaning drivers that may be positively or negatively influence both waste loss outputs and the food security index. And one component that is still under development at the later stage is the automated proposal of targeted intervention based on the selected scenario outcomes. So this is the next step that will transform the simulation results into more actionable recommendation. The tool has been implemented as an online platform available through the WasteSec website shown on the slide. So the objective is to provide a practical and user-friendly environment where different stakeholders can create simulations, compare results, and understand how their decisions may affect both food loss, waste, and food security indicators. Users can then access the platform through a login environment. There are different levels of access, including administrative access or standard user access. The distinction is useful because administrators may need to manage data, users, or platform settings, while standard users may mainly interact with the simulation workflow. After logging in, the user is directly to the platform interface. The design is intentionally simple because the tool is expected to be used by different categories of stakeholders and not only by researchers or technical experts. The main dashboard, as you can see here, gives the user an overview of their activity. From here, the user can start a new simulation. Here we go to the new simulation, but also access the list of previous simulation. So the dashboard therefore acts as the entry point for the whole decision support process. It keeps the interaction a structure and allows the user to return to earlier analysis when needed. To begin the analysis, the user creates a new simulation, writes a name. This is the core interaction with the tool because each simulation defines a specific context, a scenario that can be then evaluated. So in other words, the simulation is not a generic calculation. It is adjusted to the country role, food sector, product data entered by the user. Sorry. So the first step is to define the basic information of the simulation. The user gives the simulation the names and selects the country, selects the role in the food supply chain, could be producer, processor, retailer, distributor, or consumer. So the role is particularly important because the meaning of food loss and food waste changes along the chain. For example, producer processors generally associated with food loss data, while retailers, distributors, and consumers may be linked more to food waste calculations depending on the selected configurations and available datasets. These selections determine the baseline values that the tool will use in the next steps. Now, based on the selected country and role, the tool provides two baseline values. The first is the system waste. This is the average waste level for the selected role and country based on the available reference data, such as Eurostat data where applicable. The second is the system index. This is the baseline food security index for the selected country and constructed from the 6 pillars and then underlying parameters. So together these baseline provide the reference points against which the user's own input and scenarios will be compared. The platform then also visualizes the relevant pillar metrics in the form of bars so the users can immediately see the structure behind the index. The next step is the input stage. Here the user selects the food sector and the specific food item and then enters annual food production together with annual food waste or food loss. This step is essential because it connects the general baseline with the user's actual profile. Instead of only showing national averages, the tool asks what happens when the user's own data are introduced in the system. So after the user enters their data, the tool recalculates the system index into an actual index, and this actual index reflects reflects the user's specific situation in relation to the national base. So in the current model, the user's food loss or waste affects the stability pillar directly. The other parameters within the stability pillar are then automatically recalibrated. The other pillars are affected indirectly through the overall index logic and the scenario-based relationships. The tool also calculates the percentage difference between the actual index and the system index. So if the difference is positive, the user's performance improves the index compared with the baseline. So if it's negative, the user's performance is worse than the baseline. So in addition, the tool calculates the waste or loss rate as the percentage of the handled or produced amount that becomes waste or loss. It also provides the state-of-the-art waste status for the selected food item. So this gives the user an immediate interpretation of their own position relative to reference conditions. So the next stage is the scenario step. Here the scenario. Here the user selects drivers that may influence the system and assign a positive or negative impact to each selected driver. Examples of drivers include the weather events, storage conditions, water availability, crop protection, animal health, environmental conditions, equipment and facility management, food safety, processing and packaging, transportation infrastructure, market price availability, and input availability. In the tool, we model around 10 food security drivers, but within food security, SecureFood projects, we have identified more than 120 variables, and we have published this work. I can send you later on the literature. The tool then recalculates the results. This allows the user to explore what-if questions. For example, what happens if storage conditions improve, if water availability decreases, or if transportation infrastructure becomes a limiting factor. But on the other way around, if there is something positive, so these drivers have already been modeled and validated through a multi-actor approach with stakeholders. And this is a very, very important point, because scenario logic should reflect not only the academic assumptions, but also practical knowledge from actors across the food system. At the end of the workflow, the tool provides a summary of the simulation. So the summary includes the user's input, the calculated values, and the interpretation of the scenario. And the recommendations are designed to include several layers of information. This is, for example, the state of the art of food security in the selected country, the state of the art of food loss and waste for the selected row, and the state of the art of waste status for the selected food item. Also, general notes explaining how the user loss or waste affect the secure food index through the stability pillar, because food loss and food waste is a part of is a parameter within the stability pillar. But also recommendation on how to reduce food loss and waste while improving or at least preserving food security indicators. These recommendations may include practices, technologies, infrastructure measures, governance actions, policy-related recommendation tailored to the country, role, and food item of the user. The added value is the that WasteSec bridges qualitative and quantitative dimensions. And food security is often discussed qualitatively, but here it becomes quantifiable through the index. That was the basic idea behind this tool. At the same time, food waste, which is usually quantitative, is monitored dynamically through the scenarios. So this combination helps identify targeted intervention, especially under crisis conditions where reducing food loss and waste can directly support food security outcomes. So finally, all saved simulations remain available in the simulation tab. So this means users can return to previous analysis and compare different scenarios and track how changes in assumptions affect the results. This function is important for decision making over time. A user can test baseline case, introduce a crisis scenario, test an intervention scenario, and then compare the outcomes in a structured way. So to conclude, WasteSec is designed to bridge the gap between food loss and waste reduction and food security assessment. It helps stakeholders move from fragmented actions toward integrated data-driven strategies. Now for FEWS community, I believe this is particularly relevant because food, energy, and water systems are strongly interconnected. They are very much connected to the drivers. Decisions in one part of the system can create consequences elsewhere, and therefore tools that support scenario-based system-level thinking are increasingly necessary. Now we'll also show you a bit of directly of the tool, live how this is working, so you can assign in. Then here you see the environments, the different users, different simulations. You can create a user. I have the administration profile. You can see data, different users that have used it. And now here are the simulations. We have tested different simulations. So let's say here you go to create a new one. And you can write, for example, my name, and then select the country. We have, since this is a European project, we have modeled data from 20 European countries. But this is something now that we also discuss with the Center of the Cyber Physical Food Energy Waste Systems. We're trying to find a kind of project in order to include data also from South Africa, for example, but also other African countries, for example, from Morocco. So let's say I select Greece, and then I select producer. You see here the system waste, the system index, and also some metrics related to particularly to each of the pillars, food security pillars. And the next one, you can select the food sector. We have model aquaculture, fruits and vegetable dairy. So fruits and vegetables, for example, fresh vegetables. And then as a producer, for example, you can put the annual food waste that you have. Let's say that's 100 tons, and the annual food production, let's say that's 1,000 tons. So then key metrics are recalculated. You can see the waste loss rate, that's 10%. The actual index compared to the system, what's the difference? So then you move to the next step where you select the driver. For example, you can take weather conditions, put negative. Another driver, storage conditions, that would be positive because we improve, for example, our systems. And then third driver might be food safety, that is negative because we have a case, for example. And then you see that the scenario index, scenario waste is also actual index, and actual waste are recalculated. And finally, we have a recommendation at the final stage. We have a summary of the examined case, what we put as an input. And here will be some information about the derivation. This is the only part we have not modeled. We have actually modeled the derivation, but they have not, this kind of information have not been transferred to the tool yet. Probably next month we're going to finalize, and you can save the case, and that's all. So in order to close, I would like to thank the University of Johannesburg and the Center for Cyber Physical Food, Energy and Water Systems for the invitation, and I also acknowledge that the support of the European Union's Horizon Europe Research Innovation Program under the SecureFood project. So thank you very much for your attention. I will be happy to take any questions.
All right. Thank you very much, Prof, for that wonderful presentation and for taking us through the model for her use. I would like to open the floor and ask if colleagues or students have questions for Prof. Please, if you have a question, could you signify? All right. So we have a hand up. Oratile, please, could you unmute your mic and speak up?
Hello, distinguished researchers, guests. Just want to say thank you for the presentation. So with regards to food security, and right now I'm actually just trying to access the app. I'm sorry, the website and just how to use it. May I ask, what in 10 years, what do you see the future of food security research looking like, in especially in areas that have that are experiencing food insecurity? So for example, in say the Sahara Desert, whereby communities they are constantly struck with where there might be problems with drought, so they don't have access to constant so food insecurity can be powered by is caused by climate change. What do you see the solution for that in the next 10 years being?
Thank you for the question. First of all, okay, you cannot access the tool at the moment. It's not gonna be, it's not open anyhow, but at the moment, because we're trying to finalize it, but also it's not gonna be openly available. The tool is developed within a project, but we are planning to have a kind of a demonstration for those who are interested. Now, regarding your question about security, this is a very good question, and it's not very easy to answer it, because now for security, the problem is that we have like multiple crises, and climate change is one of the biggest problems. It's not the only crisis we face. We started, for example, with the pandemic that disturbed a lot the supply chains, and then we also have the climate change. Now we have a lot of wars. Every now and then we have a new war in the world, and everything is changing. Then so this affects a lot all kind of areas around the world, especially the prices. This is something that we have seen a lot also in Europe. Now, regarding like areas like Sahara and other desert areas that have problem with water, this is a huge problem. I can tell you, I live in Creta, that is in the just above Africa. That's like the north part of the south part of Europe, and you can see here the desertification is pretty obvious nowadays. So in regions like such as the Sahara and the wider Sahel, water will probably be the defining constraint. So I would say that future food security research will focus, for example, on climate resilient crops, efficient water management, also power desalination powered by renewable energy systems. But also I would say circular bioeconomy approaches and technologies that reduce post-harvest losses. Also digital and tools, AI, remote sensing, early warning system will become also increasingly important. These are very important. But technology alone will not solve the problem. It's research increasingly recognizing that food security is influenced by different aspects, as I said, governance, market access, infrastructure, education, even social resilience. So in many arid regions, reducing food loss and waste may provide gains comparable to increasing production, because every kilogram saved is effectively new food that does not require additional land or water. So what I see in the next years, and also regarding water, food and energy, we're gonna see some kind of optimization. There is no more time to throw away resources. All these are resources, different kind of resources, energy, water, and food are different kind of resources. They are all interconnected, and the main message I would say is that we will need to optimize systems to valorize us, not throwing anything. Yeah, not even water, less water, use less water, no waste, but also reducing the energy demands.
Thank you.
All right, thank you very much, Prof, for that response. I'll call on Prof Woolley for his question now. Prof, please, you have the floor.
No, thank you very much. Thank you, Prof Charis, for that presentation. My question stems from that popular quote, all models are wrong, but some are useful, right? So my question would be, in what context is this model useful, right? And that's where does it provide utility, significant utility the most? And then under what conditions does it break down? And in any case, what I want to seek to find out is what are the boundaries, and limitations of the model as you have developed it, And then secondly, I would want to ask, I know it's still being built in terms of timelines. Right? Has it been vetted, empirically vetted in any of these the 20 European countries that you mentioned?
So, what was the second question? Because I was confused.
No, I said the second one, has it been empirically vetted? Have you tested it? I mean, I know it's still new, but have you vetted the model practically, right? Like, say the model has given results, and then you have now seen that, say in real life, it corresponds to the results from the model, or there's a discrepancy, and by to what measure or degree?
Okay, thank you. Okay, first of all, like a few words about the model, some more detail. So the first thing we try to do is to quantify food security, because the idea was to model the relationship between food waste and food security. Food waste, you can count it, 10%, 20% kilograms, you can see how much you wasted, but food security is like a general term. So the basic idea was to develop or to use an index. So we mentioned that there is a very well-known index, Global Food Security Index from economists. They use different parameters to build up this index. So While we're also researching for the food security drivers in our research, we found a lot of drivers, a lot of variabilities, but there also was a report that suggesting to expand the classic 4 pillars of food security to 6 ones, including also 2 more. One was about sustainability. That's more a long-term run of food security, and also agency. That was a new pillar, and this agency defines what is the individual person role within food security, how each consumer, how each of us considers their role within the supply chain. So the idea was to build up this kind of index. We used different kind of parameters and data to collect to build up the index. So then we modeled this relationship. So this was the first step. The second step was to provide a kind of modeling regarding the scale up of the scales. Sorry, not scale up. The scale of each participant in the system, because like the food security index and all the kind of data, these were measured in a national level, but in for a company you cannot refer to national level. It's one company among the others, or you can if you are for consumer stage, for example, we refer the data to kilograms per capita, which is like an average. But for production, we need to also involve the production. So like you may waste a lot, for example, this is another issue. You may waste a lot, but if your production is low compared to the whole country, this does not affect so much the security. So we try to model this relationship. And finally, when we model this, then we move to the scenario, to different drivers and how they affect it, and then we use questionnaires and feedback from different end users in order to see the impact of the different drivers, the negative or positive. So WasteSec is primarily a decision support and scenario analysis tool, not a predictive forecasting model. So its main purpose is to help stakeholders understand the interaction between food loss and waste reduction actions and food security outcomes under different scenarios. So the model is particularly useful, I would say, for policymakers evaluating intervention, food supply chain actors assessing the impact of reducing loss or waste, researchers exploring a relationship between food security drivers, stakeholders interested in comparing alternative scenario before implementation. So this kind of different end user, we have it within SecureFood project, and they have already tested our tool, and we still have 2 more pilots to go until the end of the project. So then they will test it more. So what is the main outcome? So the main idea is whatever is your role in the supply chain, the tool can provide feedback to different roles. Means, for example, consumer, you can get an idea if you're a consumer, how much, for example, waste is your waste compared to the national level, compared to the European level. Are you far away? What can you do to improve it? If you are also a producer or a retailer, for example, you can see how your organization goes compared to the other organization or to the national level. Some recommendation to reduce food loss and waste, but also at the same time to maintain food security. So why do we have to maintain food security? Because food loss and food waste is not always relevant to food security. And to give you an example, let's say that I buy 50 kilos of potatoes for my house this month. Okay, if I eat like 25 kilos of potatoes and I throw away, then I throw away 25 kilos more. So then I would say, let's say, what if I buy 25 next month, 25 kilos, not 50? Okay, then I can reduce the waste this way. But on the other hand, maybe these 25 kilos are not enough for my family. So I'm not so secure. So you see, there is, in some cases, there is a level of how much I can reduce the waste without compromising food security. So these are the basic information that the users will get from the tool. And recommendation, we have the recommendation on different level. The first level is the most practical recommendation. What can you do with practical aspects to reduce waste now? And the second is more about equipment. What can you do for the company to improve a bit? And then we move to bigger scale. This is, for example, the digital tools, or can be governance, or in a more system level recommendations.
Thanks, Prof.
All right. Thank you very much, Prof, for that response. I also have a question that I would love to ask. When we were doing the simulation practice, I saw that among the drivers, it was just either a negative or a positive. So I'm wondering, how do we quantify the drivers? And are these drivers, because I think you didn't show us the whole drivers, we saw just a few. I'm wondering if this model is applicable to Africa, considering the numerous challenges, flooding, insecurity, and all of that. Are they factored into these drivers? And is there a way we can quantify to be able to say, okay, for this particular food, this is the percent of flooding that we are experiencing, in order to be able to make an informed decision or come up with specialized decisions?
Okay, thank you for the question. Now, what we did is, first of all, like as I told you, the first step of the project also was to identify the different drivers. So the basic idea was where to find the drivers, to categorize them, and then also, because there are subcategories, there are also variables within the subcategory. So we found like 100, I don't remember, there were 150 variables. We have published this work, so you can find the different drivers, and all these drivers are universal, to say, in the whole world. It's not only about Europe. The other thing was sometimes the driver could be negative or positive. So the basic idea that we implemented in our theory was like a driver. Actually, it's not a positive or negative. Driver can be positive or negative in different situations. Even, for example, climate change or other, for example, like the political situation. If you have like a governance that take measures against, for example, to support food security, then this driver is positive. But if you have the other way around, this is negative. So these drivers are universal, as I said. Now, regarding our model, because we have it's like a European project, we model for European countries. We have not modeled for African countries, as you said. How do we quantify it? We selected some drivers. We selected 10 drivers that were connected to our case studies of the project. But then we make a questionnaire and ask different actors in the supply chain to rank the impact of each driver in their company or the entity. Okay, could be consumer, could be also ministry. So this way we use this data to model then quantify the impact of the drivers in waste and also in food security. So we use questionnaires and we get the ranking via the questionnaires, and then we model this relationship. Now, the basic idea was not to provide a number. Okay, we set up the index, the SecureFood index, to have some numbers so can be comparable. I understand that for users, the end users, may be difficult to see number to actually evaluate it. That's why, although in our model we have like 10, 20 different variables, we just show in the tool 3, 4, the actual index, etc., the actual waste. There are other variables behind that we do not see to the end users, but they are used in the model. The model is the back end of the tool. in order to have some kind of metric to help us provide different kind of recommendations at different levels. Next month we're planning to finalize. We have the deliverable for this tool, and after submitting it, we're planning to publish this work and publish exactly the methodology of what we use and how we model it. So hopefully by the early next year, I can send you like publications to check more about the methodology.
All right. Thank you very much, Prof. Thank you, everyone. On behalf of the Director for the Center for Cyber-Physical Food, Energy and Water System, Professor Unwulu, I would like to appreciate our guest speaker, Professor Charis Galanakis, for this insightful presentation on the waste sec and its potential or the ability to strengthen the food system resilience and enable researchers, policymakers to make informed decisions to sustain the economy. I would also like to appreciate all our participants, all students, researchers, and colleagues present today. And I'm sure we have been able to pick a few lessons. It's no longer if we can produce enough food. It's now how to build a sustainable system, about economy system. So thank you, everyone. Thank you, Prof, for the presentation. And with that, we'll draw the curtain. Thank you, Prof. With that, we'll draw the curtain for today's webinar. And I'll see you all again next month for another edition. Thank you all, and bye.
Thank you. Bye.
Bye. Thank you.
Yeah, thank you.
Bye.